Welcome to the fifth video in this series on StorSimple 8000 migration to Azure File Shares and Azure File Sync. My name is Terry Clancy. In the first four videos we covered an overview of Azure Files, Azure File Sync and the migration process, planning and preparation for a migration, the deployment of Azure storage and migration resources, and the creation and running of migration jobs. In this video, we'll discuss how to then access Azure File Shares with Azure File Sync or AFS. We'll discuss the different approaches to access Azure File Shares, how to deploy the Azure File Sync cloud resources, and how to deploy the Azure File Sync agent on a Windows Server instance on premises. We'll then discuss how to prepare the Windows Server instance and related networking, and how to configure Azure File Sync to connect to the Windows Server instance to sync your files. We will then create the related SMB share and show how to test the overall operation of Azure File Sync. As discussed in previous videos, the Azure Files team recently released an update to the StorSimple Data Manager, so it now supports migration of data from StorSimple to Azure File Shares and Azure File Sync. The main objective of this update was to migrate data off StorSimple appliances while minimizing downtime and impact to users. To achieve these objectives, a cloud-side migration is used to avoid recalling all the data to on-prem, which avoids unnecessary delays and network congestion and avoids a jumbling of the StorSimple device cache, all of which would result in a bad user experience during the migration. And so, in the previous videos, we also discussed the deployment of the StorSimple Data Manager resource and storage account resources needed for migration of files, and how to create and run StorSimple Data Manager migration jobs. So for this video, we will assume that the StorSimple Data Manager migration jobs are complete and the data from the StorSimple backups is satisfactorily migrated to your Azure File Shares. As previously discussed, you can access Azure File Shares directly, but for faster on-premises performance and simpler networking, you can optionally use Azure File Sync or AFS with an agent running on an on-premises Windows server which caches recently used files locally. This video assumes you're going to use an AFS server and covers how to deploy, set up and use the Azure File Sync service shown here as step 5. We start by deploying the following parts of Azure File Sync. We create the Azure File Sync cloud resource. We then need to deploy the Azure File Sync agent on your on-premises server and check if any network configuration is required. And then register the server with the cloud resource. Don't create any AFS sync groups at this time. Setting up AFS sync groups triggers a sync, which should only occur after your migration jobs to an Azure File Share have completed. If you start using Azure File Sync before your migration is completed, it would cause errors and make your migration unnecessarily difficult, since you wouldn't easily be able to tell when the sync was complete and so when it was time to initiate a cutover. The core resource to deploy and configure for the cloud side of Azure File Sync or AFS is called the Storage Sync service. We recommend that you deploy only one Storage Sync service for all AFS servers that are syncing the same set of files now or in the future. Avoid creating multiple instances of the Storage Sync service, but if you do, then only do it if you have distinct sets of servers that must never exchange data. Otherwise, and in general, a single Storage Sync service is the best practice. To deploy a Storage Sync service, go to the Azure portal, click Create a Resource, and then search for Azure File Sync. If required, select Azure File Sync, and then click Create to open the Deploy Azure File Sync tab. Then start by selecting the subscription you wish to use for this resource. An Azure subscription is the most basic container for resource groups, resources, and billing. Next, select an existing resource group, or if you wish, you can create a new one. A resource group is a logical group of Azure resources to simplify management. Now provide a unique name per region for the Storage Sync service. You can use letters, numbers, spaces, periods, dashes, and underscores, and the name can be up to 260 characters. I'll use Demo of Azure Storage Sync service. Then select the region you want to deploy Azure File Sync to. Only supported regions are available in this list. choose the Azure region that's close to your location. All other related cloud resources must be deployed in that same region. Then we press Next to define tags. Tags can be helpful for cost allocation and administrative purposes. You should make sure that you follow your organization's tagging policy. For each tag, you should select or enter a name and select or enter a value. Next, you have the opportunity to review your selections and then press Create to create your Azure File Sync Storage Sync service. Next, we want to deploy the Azure File Sync agent to the Windows servers you wish to hold the cached files to be synced to your Azure File shares. These are typically on-premises servers, but they can also be in the cloud. For example, you may want an AFS server in Azure if you have on-premises servers, but you also want to allow access to the same files directly in the cloud. In this case, an AFS server in the cloud is preferred compared to direct connect to the Azure File Share. This ensures file consistency because, as previously explained, you should either access Azure File Shares using AFS or direct connect, but not both. So, you need to create a Windows Server 2019 or at a minimum 2012 R2 instance as a virtual machine or physical server. Note that Windows Server failover clusters are supported, and we recommend that you do not reuse the server front-ending your current StorSimple 8100 or 8600. And for server guidance, refer to the link on this slide and use the typical churn numbers mentioned there. Ignore the initial sync numbers because with a cloud-side migration, all your files are already in the cloud. Then provision or add direct attached storage. Network attached storage or NAS drives are not supported. It's best practice to give your new Windows Server instance an equal or larger amount of storage than your 8100 or 8600 StorSimple appliance has locally available for caching. You'll use the Windows Server instance in the same way that you use the StorSimple appliance. If it has the same amount of storage as the appliance, the caching experience should be similar, if not the same. You can add or remove storage from your Windows Server instance at will. This capability enables you to scale your local volume size and the amount of local storage available for caching. On any Windows server you plan to run the AFS agent on, you should disable Internet Explorer Enhanced Security Configuration. This is required only for initial server registration. You can re-enable it after the server has been registered. To do this, we open Server Manager, click Local Server on the left-hand side of the UI. On the Properties subpane, select the link for IE Enhanced Security Configuration, and then select Off for both administrators and users. Next, we want to install the Azure File Sync agent on our Windows server. To download the latest version, go to the link you can see here, then select and download the version that corresponds to the version of Windows Server you are using. The Azure File Sync agent is a downloadable package that enables Windows Server to be synced with an Azure file share. When the download is finished, double-click the MSI package to start the installation of the Azure File Sync agent. We recommend that you leave the default installation path as is to simplify troubleshooting and server maintenance. If necessary, configure the proxy settings for your network. We also recommend that you enable Microsoft Update to keep Azure File Sync up to date. All updates to the Azure File Sync agent, including feature updates and hotfixes, occur from Microsoft Update. We suggest that you choose to always use the latest version of Azure File Sync as they become available. You can also select a day of the week and a time of the day to check for updates, then press Install. When the Azure File Sync agent installation is finished, the server registration UI automatically opens. You must have already deployed the Storage Sync service in Azure before you can use this to register the agent. Before we can continue with registering the server in a sync group in the Storage Sync service in Azure, we need to ensure that the networking is working as required so that our AFS server has the required connectivity to Azure. To set up and use Azure Files and Azure File Sync with an on-premises Windows file server, no special networking to Azure is required beyond a basic internet connection. By default, it will work across the public internet using public endpoints. This is shown as option 1A in the diagram. With this configuration, you could optionally configure firewalls to allow only traffic to those public endpoints, but those public endpoints are shared with other Azure customers. To avoid the use of shared endpoints and to allow you to configure firewalls to only allow traffic to your own resources, you have the option to define a VNet in Azure and on that VNet configure private endpoints for the resources you need. This is shown as option 1B in the diagram. The DNS addresses and related IP addresses for these endpoints will be globally unique, so exclusive rules can then be set up in your firewalls. If you need to keep your traffic off the internet, then you should use ExpressRoute or a VPN with a VNet and private endpoints in Azure. This is shown as option 2 in the diagram. Regardless of which of these options you choose, the Azure File Sync agent achieves synchronization with the Azure File Share via 2 channels. First, the File REST protocol, which is a HTTPS-based protocol for accessing your Azure File Share. Because the File REST protocol uses standard HTTPS for data transfer, only port 443 must be accessible outbound. Azure File Sync does not use the SMB protocol to transfer data from your on-premises Windows servers to your Azure File Share. Second, the Azure File Sync protocol, which is a HTTPS-based protocol for exchanging synchronization knowledge, for example version information about the files and folders in your environment, between endpoints in your environment. This protocol is also used to exchange metadata about the files and folders in your environment, such as timestamps and access control lists or ACLs. To accomplish this, the Azure File Sync protocol uses 4 public endpoints, as you can see on this slide. These are a management endpoint, a primary sync endpoint, a secondary sync endpoint, and a monitoring endpoint. The AFS URL shown on this slide assume that your storage sync service is called My Sync Service and that it is in the West US 2 region. Of course, it will be different in other regions. In addition to this, the Azure File Sync agent has dependencies on endpoints for Azure Active Directory or AAD, Azure Resource Manager or ARM, Microsoft Update, and Microsoft PKI. All of these required connections from the AFS server require outbound connections over port 443 only. Note that if you are using AFS, then users should not use the SMB protocol to directly access the related Azure file shares, except for in the case of some administrator scenarios. This is because of the lack of quick change detection on changes made directly to the Azure file share. Changes may not be discovered and replicated to AFS servers for more than 24 hours depending on the size and number of items in the Azure file share. By contrast, changes made on an AFS server are replicated almost instantly upon file close to the Azure file share and to any other AFS servers synced with that Azure file share. As mentioned above, with an open internet connection, Azure File Sync does not require any special networking configuration. By default, it works with public endpoints across the internet. However, some customers may wish to configure advanced networking settings to enable the following scenarios. Interoperating with your organization's proxy server configuration. Opening your organization's on-premises firewall to Azure Files and Azure File Sync services. Tunneling Azure Files and Azure File Sync traffic over ExpressRoute or a VPN connection, or bandwidth throttling for AFS. The easiest approach is to set up AFS with a minimum of these settings first and get it working over the internet, and then add these settings as required. However, if required, for example by organizational policy, you can set up these networking options first and complete the setup of AFS with zero connectivity to the internet. If you need to work through proxy servers, then AFS can fully interoperate with a proxy server. However, you must manually configure the proxy endpoint settings for your environment to work with Azure File Sync. There are 2 main options for using a proxy server with AFS. The simplest is a machine-wide proxy, or app-specific proxy settings allow configuration of a proxy specifically for Azure File Sync traffic. This requires the PowerShell commands shown on this slide. For more information, see the links on the slide. If you need to configure firewalls to isolate your AFS from most internet locations for security purposes, then Azure provides what are known as service tags. A service tag represents a group of IP address prefixes from a given Azure service. Microsoft manages the address prefixes encompassed by the service tag and automatically updates the service tag as addresses change, minimizing the complexity of frequent updates to network security rules. You can, for example, use service tags to define network access controls on network security groups or Azure Firewall, and as service tag addresses change, the service tag takes care of it and there's no work to be done. The service tags relevant for Azure File Sync are shown on this slide. Now, if you're using Azure File Sync within Azure, even if it's in a different region, you can use the name of the service tag directly in your network security group to allow traffic to that service. To learn more how to do this, see the network security group link on this slide. But if you're using Azure File Sync on-premises, you can use the Service Tag API to get specific IP address ranges for your firewall's allow list. There are two methods of getting this information. First, the current list of IP address ranges for all Azure services supporting service tags are published weekly on the Microsoft Download Center in the form of a JSON document. Or, second, the Service Tag Discovery API, currently in preview, allows programmatic retrieval of the current list of service tags. For more information, see the Configuring Firewalls and Service Tags link on this slide. Some organizations require communications with Azure to go over a network tunnel, such as a virtual private network or VPN, or via ExpressRoute. This can provide an additional layer of security and can ensure communication with Azure follows a deterministic route, which can help with bandwidth optimization and minimizing latency. This is shown as option 2 on this slide. Let's look at that in more detail. Such setups require that you peer your on-premises network with one or more virtual networks in Azure. This requires that you create private endpoints for Azure File Sync and for Azure Files. Those private endpoints are then used to connect those services to your Azure VNet. Once you have peering set up and connectivity to those private endpoints, you would normally disable the public endpoints for Azure File Sync and for Azure Files using firewall settings on the related resources, which, by the way, are the Storage Sync service and the related storage accounts. Beyond Azure File Sync and Azure Files, you also have options for Azure Active Directory, ARM, and Microsoft Update. With Azure Active Directory, or AAD, you have two options. Use a public AAD endpoint or configure private endpoints. For Azure Resource Manager, or ARM, you have two options. Use a public ARM endpoint or use Azure Private Link to enable private access to Azure Resource Manager from your virtual networks without crossing the internet. This capability is currently in private preview. And with Microsoft Update, you have two options. Use a public Microsoft Update service across the internet, or use Windows Server Update Services, WSUS, which enables organizations to deploy the latest Microsoft product updates. You can use WSUS to fully manage the distribution of updates that are released through Microsoft Update to other computers on your private network. For Microsoft Public Key Infrastructure, or PKI, you can use the public endpoint, and we are still investigating the options for private connections. For more detail on any of these, see the links on the slide. For any AFS server, you can set a bandwidth throttling schedule. Note that throttling applies to uploads and regular sync downloads. Throttling will not impact users who are recalling a cold, tiered file because the goal is to get the user or app the file as quickly as possible. To establish a throttling schedule, first import the Storage Sync Agent Server Commandlet's PowerShell module and then use the PowerShell commands on this slide. Note that network limits that overlap in time are not allowed. Also, if you want to set a limit for a time period that spans 2 days, then you need to split it up and configure it separately for before and after midnight. Here is an example of a schedule that throttles bandwidth to 50 megabits per second from 7 AM to 7 PM Monday to Friday and 100 megabits per second at other times. Note that the overlapping time periods have been avoided. After your networking is set up correctly, you're then ready to register the AFS Windows Server to your Storage Sync service. Registering your Windows Server with a Storage Sync service establishes a trust relationship between your server or cluster and the Storage Sync service. Note that a server can only be registered to one Storage Sync service and can then only sync with other servers and other file shares associated with the same Storage Sync service. To register the server with your previously configured Azure Storage Sync service, first select your relevant Azure environment. Then, sign in with your Azure credentials, and then enter the subscription name, resource group name, and Storage Sync service name, and then click on Register. All going well, you will then get a notification of registration successful, along with a link to the results of a network connectivity test and a button to copy an Azure resource URL. If you open the results of the network connectivity test, you will see a screen like this one. Note at the top the PowerShell script required to get this information at any time. Whereas Azure File Shares have just one public endpoint, as mentioned earlier, Azure File Sync uses 4 public endpoints, one for management, one for primary sync, one for secondary sync, and one for monitoring. This report shows the result of a test of those endpoints, but note that the primary and secondary sync endpoints are missing because we have not created a sync group yet. After you create a sync group, run the PowerShell script at the top of this report for an updated report that includes the primary and secondary sync endpoints. Also note that the management endpoint is used by both the Discovery service and the Management service, and so it is shown here twice. You will also see 2 entries for the monitoring endpoint. The first, starting with demo of Azure Storage Sync monitoring, is used if you set up private endpoints, and the other, starting with Kialani prod WEU1HM, is used if you are using public endpoints. So, this report tells you the communication AFS needs and why. You can use the report, for example, to provide the information you need to lock down the firewalls around the server to specific URLs. It is recommended that you copy or screenshot this report for later reference. The button labeled Copy Azure Resource URL simply copies to the Windows clipboard the deep URL which takes you directly to the management page for the Storage Sync service in the Azure portal. After successful installation and server registration, you can go to that page to confirm you've successfully completed this step. In the left menu, go to Registered Servers. If all went well, you'll see your server listed there. Before we set up our AFS Sync group, now is a good time to install the AFS PowerShell module. There will be times you need to use it to configure or debug AFS. There are 2 modules. az.storagesync contains the commandlets that interact with the Azure File Sync related resources in Azure via ARM. Whereas storagesync.management.servercommandlets.dll contains the commandlets that interact normally locally with the AFS server. First, start PowerShell using Run as Administrator. Either PowerShell command line or PowerShell integrated scripting environment is fine. I will use PowerShell command line. Then, to install az.storagesync, use the following commands. First, install module, name az allow clobber. The AZ PowerShell module is a set of commandlets for managing Azure resources directly from PowerShell. The allow clobber switch allows it to overwrite any modules already installed with the same name. Note that this installation can take some time. Then run install module name az.storagesync. Then, to install storagesync.management.servercommandlets.dll, run this import module command and your environment will then be set up so you can run AFS-related PowerShell commands as required. We can now, for example, run the test storage sync network connectivity commandlet discussed earlier to test communications with endpoint URLs specific to this server. This commandlet can help troubleshoot communications problems and be used to fine-tune proxy and firewall configurations. Now we have all the infrastructure in place, we're ready to define our AFS sync group and related cloud endpoint, which is the Azure File Share, and one or more server endpoints, which will in turn create and sync to a folder on our AFS Windows server. Immediately after you define the server endpoint, files will start syncing. So it is very important that you have confirmed that your migration of StorSimple files and folders into the Azure File Shares is complete before you proceed. If not, and if migration and syncing are ever running at the same time, errors will occur. After you start this process, it is recommended that no more changes are done to the Azure File Share directly, other than what AFS does. Said another way, from this point forward, all changes should be made through AFS so that changes are immediately propagated to the Azure File Share and any related AFS server endpoints. Also, your registered on-premises Windows Server instance must be ready and connected to Azure for this process. We have previously done that in this demo, so we are good to go. So this is a step which ties together all the cloud resources you configured with folders on the Windows Server instance you configured during the previous steps. This step includes the creation of a cloud endpoint for which you need role assignment rights which come with the owner or user access administrator built-in roles. So you need one of those roles to create a sync group. So when you are ready to create a sync group, after you sign into the Azure portal, locate your Storage Sync Service resource and click on the plus sync group to create a new sync group. Each sync group is attached to one and only one Azure File Share. In Azure File Sync terminology, the Azure File Share will become the cloud endpoint in the sync topology that you're describing with the creation of a sync group. When you create the sync group, give it a familiar name, typically similar to the related Azure File Share, so that you recognize which set of file syncs it manages. My Azure File Share is Demo Azure File Share 1. So I will call the sync group Demo Azure File Share 1-sync. Then, to specify the cloud endpoint details, define the subscription, storage account, and Azure File Share names. After you create the sync group, a row for it will appear in the list of sync groups. Select the name to display the contents of the sync group. You'll see your Azure File Share under Cloud Endpoint. Now, let's add a server endpoint. Locate the Add Server Endpoint button. Select the registered server, enter the local AFS Windows Server path of the folder you want the namespace to sync to, and note that that path should not currently exist. This process will create it for you. As an aside, note that if your AFS server is a VM in Azure like this one, then by default the D drive will be temporary storage and should not be used, because files would not persist after reboots. In that case, you should attach the managed data disk to your Windows VM, initialize it, format it, and use it as your caching volume. That's what I'm doing here, and as you can see, I have set it up as the E drive. Now, back to defining our server endpoint. And the next step for that is to turn on cloud tiering. Cloud tiering is the Azure File Sync feature that allows the local server to have less storage capacity than is stored in the cloud, yet have the full namespace available. Recently used files will be cached locally for fast local access performance. Another reason to turn on cloud tiering at this step is that we don't want to sync down file content at this stage in the initial sync. Only the namespace, not the file content, should be synced down to the AFS server in the initial sync. Next, set volume free space. This is the amount of free space to reserve on the volume on which the server endpoint is located. For example, if volume free space is set to 30% on a volume that is only used for one server endpoint, then up to 70% of that volume can be used to cache files for that sync group. Regardless of whether cloud tiering is enabled, at all times your Azure File Share always has a complete copy of the data in the sync group. Note that you can have multiple server endpoints on a volume as long as they do not overlap. If you do, then the server endpoint with the highest volume free space takes precedence and becomes the effective volume free space for the other endpoints, which then share the remaining space to cache files. Then, optionally select the initial download mode. This can be helpful when there are files in the Azure File Share but not on the server, such as is the case with a StorSimple migration using the StorSimple Data Manager migration tools. If cloud tiering is enabled, as we suggest, then we normally recommend that you leave the default selection, which is to recall the namespace with no file content initially. That is useful if you believe that user access requests should decide what file content is recalled to and cached on the server. If cloud tiering is disabled, the default is that the namespace will download first and then files will be recalled, most recently used first based on last modified timestamp, until the local capacity has been reached based on the volume free space. You can, however, change the initial download mode to namespace only. A third, rarely used mode can only be used if cloud tiering is disabled for this server endpoint. This mode avoids recalling the namespace first. Files will only appear on the local server if they have had a chance to fully download. This mode is useful, for instance, if an application requires full files to be present and cannot tolerate tiered files in its namespace. To add the server endpoint, select Create. Immediately the sync process starts and very soon files will be syncing and flowing down to the AFS server. Now you need to know when the AFS initial sync is complete so that you can know when to proceed with the remaining steps of the migration. There are two options as to how to check if the initial sync is finished. The first uses the AFS server event viewer and the second uses PowerShell commands. For the first option, open the event viewer on the AFS server and go to Applications and Service Logs, Microsoft, File Sync, Agent, Telemetry, and then filter by event equals 9102. Then look for events with sync direction of download and hresult equal to 0. Keep checking this every hour or so, or every day or so for very large shares, and when you see a 9102 download event with hresult equal to 0, then you know that the initial download is complete. The second option uses PowerShell on the AFS server. You should first ensure that you are running the latest version of the az.storagesync PowerShell module by entering the import module and the get module commands I'm showing here. Then enter the following script, substituting your values where appropriate. The last 3 lines will display the upload and download last sync mode. You should keep running these 3 lines every hour or so, or day or so for large shares, until the last line shows the value of download status last sync mode to be regular. After the initial download is complete, if the Azure Portal UI for the Sync Group Server endpoint shows any errors, refer to the link on the screen for guidance in correcting any issues. Minor issues such as unsupported characters in file or folder names are not uncommon, so don't panic if errors are reported. Once the AFS server has successfully synced the namespace, you can then proceed to do a functional test of the AFS server. To test that AFS is working, open a remote desktop session to your AFS server and confirm that the folder you defined as the path to sync to has been created and exists. In that folder, create a test file with some test content. I'll create a file called afsdemotest.txt. Now, log on to the Azure portal and go to the related Azure file share. Check that the file you created now exists in the Azure file share. If it does, then AFS is working as expected. Once the sync group initial sync is complete and the AFS is confirmed to be working, then on your AFS server you can create the Windows Server SMB network shares that your users will ultimately use. You can either share the single server endpoint folder to which AFS is syncing the namespace to, as shown on the left in this diagram, or share several descendant folders underneath the server endpoint, which allows you to have multiple SMB file shares per sync group, as shown in the right-hand side example in this diagram. If, as recommended, your AFS server is a different server than you use with StorSimple, then you can use the same share names, or you can define new ones. To share a folder, first use Server Manager to confirm that the File and Storage Services role is installed on Windows Server. And then, while you can use Windows File Explorer and navigate to the folder and select Properties and use the Sharing tab, the preferred approach is to use the Windows Server New Share Wizard, as it provides more options that you may want to use. In the Server Manager left-hand pane, navigate to File and Storage Services, and then Shares, and then under Tasks, select New Share. Then select the profile for this share. You will normally want SMB Share Quick unless you have some of these more advanced requirements. Select Next and then select Type a Custom Path and navigate to the folder you want to share. In this case, I will select the server endpoint folder that was created by AFS when I created the server endpoint. Select Next and define the share name. I will leave it the same as the folder name. Then select Next and select any share settings you require. All these settings are okay and can be used with AFS. If in doubt, stick with the defaults as I will here. Next, on the Permissions page, select Customize Permissions and then select the Share tab to configure who can get into the share. Share permissions are like a gate. Once users are into the share, then NTFS file and folder permissions take over, but you have to allow individual users and groups through the gates to get into the share in the first place. That's what I can set up here. At this stage, you should add people you want to access the share for testing purposes with the appropriate permission levels. Note that the StorSimple Data Manager migration tools migrates NTFS ACL permissions for all files and folders migrated, but it does not migrate these share level permissions. Later, during the cutover, you will need to add user permissions here, but do not do that yet. Wait until the final catch-up robo-copies are complete. Configure any other options you require and then click Apply. Once you are finished, test the share is working by connecting to its UNC path, which has the format /servername/share name. At this point, the AFS agent on Windows Server is connected to the Storage Sync service in Azure and other required resources, and it is currently syncing files to your Azure file share across fully encrypted links. We also now have a functional SMB share with a copy of all the user data from the StorSimple backup taken from before the beginning of the migration. At this time, your users should not be able to access that SMB share. What remains to be done is to run catch-up robocopies to catch up on any changes that users have made since the migration began. Then, take downtime while you disconnect users from the old StorSimple share, run one last robocopy, and then reconnect the users to the new share. This can then be followed by the retirement of StorSimple and any other resources that are no longer needed. We'll cover these steps in the next video. Here are some resources you can leverage to help plan your StorSimple migration and to learn more about Azure File Shares. And here are some links for Azure File Sync and the StorSimple Data Manager migration tool. Should you have any other questions we could answer, feel free to contact us at storsimp@microsoft.com. That is StorSimp@microsoft.com. We hope this video series provides you with the necessary information to complete your StorSimple migration. Thanks for listening, and we wish you all the best with your migration.